Last but not least, we have the bottom part of our section. Now these two problems can be solved in a similar manner. We'll solve one of them together, and then we'll see if you can solve this second one on your own using the same process. In example 2, we have a 100-year-old redwood tree that's 190 feet tall. When it was 50 years old, it was 125 feet tall, shorter than it was at 100 years. Use these two data points to create a linear model. We've seen those words before. That tells me I'm thinking regression or writing an equation. Use that model to estimate the height of the tree when it's 80 years old. So it sounds like, as I'm looking at this, the 100 years and the height of the tree, I believe the height depends on how old the tree is. So I have a dependent and an independent. The height of the tree depends on the age of it. So age determines height. If that's the case, and that seems like to be true, the ages and the heights, we can now create some ordered pairs. The 100-year-old tree is 190 feet tall. And the 50-year-old tree is 125 feet tall. I can use my knowledge from Unit 1, where we put all of our x values into list 1 and our y values into list 2, and created a linear regression with that data. I need to enter in just these two data points. I'm working in my list 1 and list 2. I have 100 years and 50 years, 190 feet, 125 feet. And now I'm going to run that regression. Reminder, stat, calculate, linear regression using list 1 and list 2. If you'd like to store it in a regression equation, you can go ahead and do that now. I like to take advantage of that, so I'm going to use my vars key. If you have the other interface, you're simply doing list 1, comma, list 2, comma, and now this vars sequence. Vars, yvars, function, y1. And when I calculate, it gives me the equation. The height of the tree equals 1.3 times the number of years old it is plus 60. To interpret what this means, a tree starts off at 60 feet tall and adds 1.3 feet per year it is allowed to continue growing. That helps me out with what the slope represents. The slope is the coefficient in front of our x variable, in front of our independent variable. This slope tells me the rate. Slope and rate are interchangeable words. And since I'm thinking about how much height is changing for every 1 year of age, this would tell me it grows 1.3 feet of height is added each year the tree is alive. Our slope will always be our rate, and it tells us the change in our dependent variable based on 1 unit change of our independent variable. Now, last but not least, I need to think about what happens the height at 80 years old. So this is when our time equals 80. I can either plug 80 in right here, or I could go use my table. I can use my table because that equation is sitting right here in my y1. So if I wanted to use my table, I could simply go there and scroll down until I find an x of 80 years old. Now to speed that up a little bit, that table setting right here and my calculator can take me exactly right there. So by hitting second table set or second window, I can tell it where I want my table to start. If I'm interested in 80 years, I'm going to start my table at 80. And now when I go to my table, it starts at the exact year I'm looking for, and it tells me that a height at 80 feet is 164. I'm sorry, at 80 years old is 164 feet tall. I could have also solved this simply by doing 1.3 times 80 plus 60, just plugging it into this equation here. 1.3 times 80 plus 60 gives me the identical answer. Try this one on your own, keep on playing with the video, and it'll give you the correct answer.